Hello and welcome back to the stream. So today I'm going to be so this is kind of what I'm calling an extra um, stream outside of the usual time slot I have for this writing a programming language series. So in general, I'll be doing kind of a regular slot where I'll be focusing more on implementing language features and doing more exciting stuff during the Saturday 3 o'clock slot. But then in these kind of extra sessions, they're going to be a little more toned back, probably not as fast moving, probably less narration as well. Just sessions where effectively I'm just going to be, working through my own thoughts, trying to get things working in the background, and just kind of streaming them and uploading them for the sake of sharing them. But content itself is probably going to not be the most exciting. So it's more, yeah, it's an extra type of stream. It's not the kind of main content I'll be focusing on in general. So what I'll be doing today basically will be continuing on where I left things yesterday, or from where I left things yesterday, which is trying to get this kind of an environment structure working, where we have an environment consisting of a frame, but can also point to a parent environment that also has, say, name bindings and things like that. And the main issue I'm trying to resolve at the moment is this this iteration uh, through through the environment stack for a given environment, so that we can try to resolve a variable binding you know in various scopes, one after the other, but trying to do that in such a way that we're not messing up with parallelism. So we're using mutexes, but we also need to be careful around locks when dealing with the borrow checker. So the borrow checker is kind of the primary antagonist here at the moment. It's the hero really, but it's making things less than easy, shall we say? So the main issue at the moment is we have this environment structure is essentially defined recursively, but we want to be able to more or less go through the different environments and stack frames that are defined in it. We want to iterate through those, but because of this parent structure and the fact that we're using arc mutexes, which are kind of locked areas of memory, we're running into basically an issue here where we're unlocking a parent environment, checking the environment, and then if we don't find what we want there, then we try to access the parent of that. But when we're trying to access the nested parent, we run into issues with the fact that we've already locked the outer environment, and when we're about to iterate on the parent, we drop the lock, so that when we're trying to access the parent, we don't have that lock anymore, and that's kind of throwing up an interesting issue. So I've been doing a little bit of messing around in the background, not too much. So I've come up with this so far. So it's a slight bit of unrolling. So let me uncomment what I had before, just as an introduction. So what I had before was this kind of more primitive approach where we just so the start of the function basically just checks the current environment stack frame for what we're looking for, and if it's there, then we return it. But if it's not in our current frame, then we basically create a pointer to our kind of current node that we're examining, which may or may not have anything in it, and then we keep iterating until the parent becomes none. And at each step, we try to unlock the frame or to lock the frame at that point, uh, do a bit of checking of it, and then move on to the next one if we don't find what we want. And here's the area where it's throwing up an issue. In fact, I can compile this and it should give us the error that we're seeing before, which is essentially once we get to the end of our little scope here, we're updating our, say, current pointer to reference the parent environment, and like in what we call it, and in an imperative situation, we're basically just kind of iterating through the nodes in the linked list. But because of the recursive nature here and the workings with the locks, essentially, once we are looking inside a locked variable during the scope where it's unlocked. But then once we reach the end of the scope and want to iterate again, we kind of lose that reference, which we can see here. And like this is probably a much more concise way of saying that is, yeah, we're accessing a variable in here and updating our reference, but the value that we're borrowing doesn't live long enough. So that's the issue that I'm trying to combat at the moment. And the first, in fact, if I go back a bit here, one of the issues I'm considering as an issue is the fact that we kind of have this reference to an option. And when we get down here, we're doing a reference to an inner option, and it's, the environment reference gets dropped at that point. What I was thinking might be a little smarter is the fact that because we can't this is kind of throwing us for a loop, the fact that we're kind of maintaining inner references, I think. Whereas what we could potentially do is if we were able to unwrap this bit and get it outside of the option, which the compiler was recommending us before, I think. But basically, if we have this, then instead of having a direct reference, we might be able to clone the reference, which, to be honest, again, I'm still getting to grips with Rust. I'm not sure if that makes sense as an approach, but it's just something that I was trying out. And beyond that as well, so that's currently what I'm looking at here. It involves a little bit of loop unrolling, which I might roll back up again later if I can. But some other options presented themselves as well after a little searching. So there's a series called Learning Rust with Entirely Too Many Linked Lists, provides some things that could be tips in this scenario. In particular, it defines an iterator over a linked list, which is something that may or may not help us if I decide to create that kind of an abstraction to maybe try and make the iteration a bit clearer, perhaps, and try to disassociate the locking mechanism. Another option that so this is actually kind of more or less the same thing as well. It's I was taking a look at the so from Aloso's blog, again defines an iterator down here. Again, it's a by reference iterator that could bite us because that's kind of what we're battling with at the moment. Another idea that I'm toying with as well is yesterday I was debating different approaches for environments in general, and I was talking about a kind of an environment pool where I was maintaining indexes into that pool, so that I wouldn't be you could just clone those environments directly, and you're not cloning direct memory, you're just cloning references into that memory. However, and I was talking about the difficulties with that being that if any of the environment stuff changed, then I'd have to update loads of indexes, and it'd be a lot of kind of bookkeeping. But what I disregarded is the potential for doing something more like this, where we have an environment definition, and again, we have frames, but it could just be defined as, let's see, so if we defined, again, had a type which was frame, and it was something like this, then what that would allow us to do is have an environment which would be something like this, perhaps a vector of arcmutex frames. Yeah, and something like this would allow us to have, it would essentially be the pool approach again in a sense, but the pool is kind of defined like it's more abstract. It's just in the background. It's not something that we maintain directly. And this is actually something that I'm feeling is going to be more likely to be the correct solution in the end, because this this recursion approach could be quite a bit trickier. But I'm just going to take another stab at it, see how it works out, and follow up with at least we have this backup approach anyway if things don't work out. So let's take a look here. So where are we now? So we've unwrapped the first option, and so we're getting this arcmutex. So we've now got kind of a more direct reference, I think, to a nested environment, and so we're cloning the reference so that it's to be honest, not sure if that's going to make too much of a difference, but it might. We'll see. This part is, there's going to be a lot of experimentation here, a lot of unknowns. So yeah, we'll see how it goes. Anyway, so we cannot assign to parent prime because it's borrowed. The borrowing starts at the top here when it gets locked, and then I attempt to assign it down here where we're doing the same as up here and just assigning the inner we're assigning the inner parent to parent prime, which is kind of the current node marker. And that's probably not going to work out, because no matter what we do, parent prime is going to be borrowed for the lifetime of environment, and then if we try to get the parent element or the parent field of environment, that's never going to really work, is it? Because it's going to be locked for that that whole scope. So that might even that might be just a raw limit that that I have to accept. So maybe it's actually time already to just try out this this vector-based approach. So let's see if first of all, if I just redefine it like this, is it going to kick up some type issues first of all? I know there's going to be some errors down here in terms of the method implementations. In fact, maybe I'll comment out the method implementations as well, just so that just to make things easier for myself for the moment. Implementation for type defined outside of crate. Even though, am I not defining that there? Type aliasing in cat. Rust type alias. So it might be the way that type aliases are one-to-one, and in which case, yeah, it makes sense that I wouldn't, if I wrap it in a struct, I might be able to do something with it, but maybe a more straightforward question of type alias info. Oh, new type pattern. That sounds more like what I'm looking for. Because I think Haskell is something like new type, where it's not necessarily just an alias; it's actually a new type that operates more or less the same as the original, but they're not necessarily you can't just assign one to the other, I believe. So there's a new type pattern. Okay, that looks like what? Okay, yeah, that makes sense. So that's more like what I probably need to do. So, and that just struct, and it's a tuple type. So I'll be accessing it using 0. And should I do the same for frame? I'm not sure. I won't worry too much right now. Anyway, so running into issues here with main. Yeah, that should be easy enough to resolve. 33. Ends wouldn't need to then be wrapped in those arc mutexes, because they'd just be a list of mutex frame elements. So I might need to change that. Just do that for now. I should define a new function for it, but although maybe it won't be too difficult to do that. I don't think. Oops, Rust. And it looks like it doesn't take self in that case. So we would just do takes a vector of frames. I'm actually going to copy these files just for the moment, because I see myself making a lot of changes here. And I know I can go back with Git, and I should probably put a snapshot or something in, but sometimes it's as easy to just duplicate the files in the short term. That's in a val 346. So that's when I'm creating a new environment. That'll be interesting. So yeah, so we won't need the locked stuff anymore. Can just do, so the new frame is still relevant. Yeah, I might as well just dive in and start replacing all these arcmutex ends with plain ends for the moment. And that'll simplify that actually. It'll get around the headaches I've been having there. And that should be about it for that. Oh, 20 errors from that. And let's see where to begin. From all those env clones. Okay. Env.clone can just, yeah, maybe all those arcs will be better off as references, maybe. Shouldn't need those anymore. The clones won't be needed either. Instead, those will be back to what they had been before, either regular references or moved. And I'll get the borrowed checker to tell me which ones should be which. So line 54 and get, yeah, so I just replaced that. And insert will need the same treatment. And basically just undoing a lot of the changes I made yesterday for wrapping things in arcmutex. 348. What's this up to? So this is now, yeah, this is the interesting part then. So creating a new environment will be something along these lines. So it'll be, can I do a clone push, or I'll probably no, I'll probably have to. So I'll take the current environment, and that should clone all the references in it, so that the new vector, the new stack should still be referring to all the same frames as the existing environment. So I'll call that env prime, and env prime will push, so that will be a frame, and then I'll push, or I'll pass the new environment. Oh, so I have to do something like, yeah, I'll have to make env clonable. I'll tidy that up in post. For now, something like that should be close to what I want. Yep, can just borrow that. Expected a vector but found an env, yeah. Push frank. And 3, 4, 7. That should be an arc. Yeah, that's cool. So that'll be arc new, and this will be mutex new. And 38, is that in main? Yep, 38. So we're not doing my locked env anymore, it'll just be a regular old env. Probably won't need these guys anymore. Constructor not visible. Oh yeah, so I'll have to make that new, and I'll need to actually make that public. 3 errors still, so what's going on here? So first of all, in eval we have line 194. Yeah, that's some remnant stuff. And then everything else is in main, so line 34. What's going on here? And vals is just a single frame, so I want to update that, and so that will need to be a vector. I have a lot of cleanup to do here, but I really want to just see if the concept actually works first. Oh yeah, and that'll have to be. Also, I will need arc and mutex there, and so that I can wrap that up. Oops, no, wrong place for that. And there was something on line 38, wasn't there? Expected a pointer or a reference to an environment. And let's see, line 34, I probably messed up the brackets here, did I? Nope. Use struct literal syntax instead. Ah, interesting. Oh, that's just me being silly with syntax. And now the borrow checker is throwing up some issues. Yeah, makes sense that it would. So, oh, but only 4 actual borrow errors. Okay, that's not too bad. I was thinking that I'd need to update all the parameters to the different function calls, but this could be all right. So move occurs here. In fact, maybe I'll xenv. Just split things up onto different lines to make the errors maybe a bit clearer. So move occurs for the vector. Okay, so okay, env0 is behind a shared reference. So what I want to do here actually is clone that. So that'll be maybe the envvec for the moment. And again, these names are going to be very temporary. Can't borrow is mutable. Very fair. 194. Insert is a yeah. I think that's fair too. If, yeah, I'll just comment that out for the moment. I'll come back to that. I'll put a big to do there. Don't want to comment. I don't want to commit that by accident. But just want to double check that. Like, I assume that if I want to mutate something that's referred to, that has an arcmutex reference from within env, I assume that env itself needs to be a mutable reference as well in order to pull that off. But just want to check that out for myself. And line 71, same thing there. Oops. So compile that. Okay, so it's where at least the types and lifetimes are checking out now at least. So now the next thing to do, and this is kind of the moment of truth here, is to iterate through the frames and see, can we get what we want? And I have a bit more confidence in this one now, I have to admit. So we could probably do a for loop here. So something like for frame in, so this is self 0. Yeah, so it's a vector. And I want to lock the frame to get frame. Maybe unlocked frame get, and that could be it. It would simplify things a lot, and it would only be made possible because the borrow checker forced me to. But if it looked as something as simple as this, it'd be quite cool. So none wasn't expected there though. Wonder why that is. Unexpected token. Oh, because I still have a none at the bottom there. Yep. In fact, I'll get rid of all those comments. They should be there, saved in the backup file. So a move occurs. So I'm going to, need to iterate over a copy of it. Nice. That looks like it could work. And as natural as it is for me to operate in terms of recursive data types, this just looks a lot simpler. So let's try. So let's look at insert next. So inserting will modify the top of the environment. So let's see, this will be an interesting one. So an environment should always have at least one frame, and yeah, so an environment should always have at least one frame, but that's a constraint or a requirement that we're defining kind of at the code level, or at the runtime level, not at the type level. So we don't have this you know, it's not non-empty by construction, it's non-empty by assumption. So even though we can do, make best efforts to make sure that the vector is never empty, and we can even add some assertion up here during the construction to make sure that at the type level, we'll still need to do checking for that, just in case, because even if we build those invariants in at at the start when we define our types, who knows how this project could evolve, and some of those invariants could get forgotten. So it's no harm to have those invariants asserted at the point that they're going to be relied on. So what do I mean by that? So it just means that even though in general I assume that the vector will never be empty when I'm accessing it, I just need to double check. So is there a head method? Probably not. There's probably just a get. Is there no get? Do you have to use indexing? And does indexing panic, or does it return an optional variable? So pop returns an option. Is there a Rust playground? I can just see what type. Oops, no. Play with Rust Lang. And I just want to see what type a get returns. Woohoo. Roll. Okay. Yes, is this that's probably some code that I was playing around with that I saw on Twitter before. I think this was Loiga's code for or at Loiga, their code for kind of type polymorphism, I believe. That was a while ago. Interesting that I remembered all that. So I'm going to do something like vec 1, 1, 2, 3, and it's going to be a let x's equals that, and let I8 is equal to x's 1, and then yeah, we'll do a print line there as well. Do I need to import anything? Don't think so. And yeah, we'll do a print then for good measure, and run that. That just shows I'm rusty at Rust. Okay, and so it's not an option type. So if I do an out of bounds, then it's just going to panic, I'm guessing. Is there a way of doing a non-panicking get? Let's see. Now, could be in all those traits. So I'm not going to go through all of them. So I'm just going to start messing around, basically. Is that a method that exists? Ah, yes. So where is that defined? Get vget. And where could I find that in the index if I wanted to? Because it doesn't show up there in the main ones. I'd have to methods from dereferencing. I never checked down there. I'm guessing I'm missing out on a lot of very important stuff. Returns a reference to an element, and it comes back as an option. So that's what I'm guessing I'd be looking for here. So idea here is, so frame get 0, unwrap it. Can you do unwrap or error? Oh, expect, is it? Don't love expect because it's not, you know, because you're just throwing a string error basically, so you're not really going to be able to catch it or handle it so well at a higher level, but it's better than panicking anyway. So, or in fact, no, because this panics as well. But at least I can customize the error in this case. So env stack shouldn't be empty. Like, I don't love that, but should be fine for now. So we get element 0. That would hardly get a mutable reference. There's probably a get mute is there. Where were those methods? Get mute, yeah. Actually, I'm going to leave it the way it is, because sometimes, just in order to get more familiar with lifetimes in Rust and what the different errors means, I just intentionally run into the borrow checker wall, and resolve the pieces one at a time, just to work through it in more detail. So let's see. So I'll get the frame, and it'll be self-0 now. I'll probably change that into a non-tuple version at some point. It's all right the way it is at the moment anyway. So we get the, oh, that's not going to be the top element of the list at all, is it? It's going to be the bottom. So we want the, it does have last and it has first. Oh, interesting. And you can get a mutable pointer to it. Okay, interesting. So, and what would happen if you called it on an empty list? I assume. Yeah, it would be none in that case, I assume. So there's no type for that. So because it returns it. Okay, interesting. Oh yeah, borrowed copy of it can't be interesting. Can it be done with the debug formatter? Yeah, none. Okay, yeah. What you'd expect, but yeah, I like to verify stuff like that from time to time. So let's see. So we get the frame. Oops, that should be last. Assume that something is there, and then when we get it, we'll insert, we'll add a new binding to the, should probably call it something other than insert, like insert into top scope or top frame. But yeah, that's something to clean up later. No method named insert. Ah, yes, because we'll have to lock that. We'll have to unwrap it. Again, that's a place where I could probably do expect instead, but for that one, I think it's a little clearer that we'd expect that that getting a reference at that point, like if it fails, that's probably above our pay grade to try and handle that. And that seems to compile at least. So, you know, that's a big chunk of the battle. So with that in mind, I might be able to go about actually cleaning up the rest of the code and updating and maybe getting this maybe getting function calls actually working. So let's see, self frame insert not needed at the moment. What I'd like to add potentially is a new push method just to clean up that little bit of the code here that was looking a little messy, I think. So the idea is that we'll take an environment and a new frame, and we'll take care of this stuff in situ. So we clone the existing stack, push the new frame, and return a new environment. And so that should allow us to do what we're doing up here a little more simply. So we go env push frame, and no, that things are going a little too well for a little too long. So what's the issue here? No, nothing named push, so that should be frames. Envec, so that's over here, I'm guessing. 423, no, oh, it's here. And what's going on in self? Okay, and so the last thing to probably worry about here is the inserts, the to-dos that I commented out earlier. And will that just work? Expect a string, but insert, can I just borrow that string? I'm guessing not. Doesn't seem to matter. Why is that? Line 430. Oh, it's happening here. Ah, interesting. So is it actually nothing to do with that? Why is that only happening when I call the function? Surely if it's so now the error is on line 71, and if I remove the clone, it's still on line 71. To string. Okay, what's going on here? Oh yeah, so it has to be mutable. That makes sense. Maybe if I just change that to mutable first, will that resolve things for me magically? So I'll need to change all of those to mutable references, I think. And that. I'll have to update main anyway, but value 149. Did I name them badly? Oh, yeah, did a mistake there. 971, what's going wrong? Still need the conversion. Can't borrow as mutable. Because it's not declared as mutable. So what line are we on? Line 34. It's because it's not declared as, oh, looking at the wrong file. Yeah, that makes total sense. I'll update that to frame, and we'll call it global frame. Whoops. Because that's basically what it is. And let's see, line 348. Can't borrow as mutable. Try removing the mutability there. Types differ in mutability. Whereas the val statements defined. So it takes that. Okay, line 34. I'm not fully following what is what's gone wrong in some of these places, but it seems to be resolved. I don't love programming by coincidence, but for the most part, I think the code itself is doing what I want and expect. It's just in terms of getting the types all jigsawing together that yeah, I'm basically just following what the compiler tells me to do, and like that makes sense to a certain degree as well. You know, the solution to a problem in a lot of cases isn't necessarily what the human operator thinks and isn't necessarily what the computer thinks. You know, it's somewhere in the middle, and that's why we have unit tests that aren't always going to, you know, give us necessarily the right answer, but you know, it's going to inform both sides so that the computer and human can converge on an answer. So what is the answer in this case? Okay, so variable definition seems to be working again. So in that case, let's take a look at the sample code. So first we go is less than 2. So we give this a proper name. And in this case, so what's happening here? So it's saying, so we are in the context of this function, but n isn't defined for some reason. And in fact, if we just print it in, n isn't defined. So what could be the reason for that? So it could be that there could be a number of reasons for that, actually. I suppose let's do a little bit of testing first. And see, is variable assignment working in general? So it does seem to be working in general, and we were able to the function definition got found in the environment too. So with that in mind, let's see if we can do something like this again, just to narrow down the potential problems. And is it just a problem with defining the parameter list? So yeah, so assignment works outside a function and inside a function. The main thing that's going wrong is defining the new stack frame. I'll get rid of the old environment definition that used linking. So where is the invocation of environment push? Here we go, very cheeky. And again, probably a very good argument for why I shouldn't use this kind of X prime notation, because it was very easy to gloss over. I just didn't pass the correct environment. So so that should be a mutable thing. No, should it? All right, that is very cool. Nice one. Okay, so function calls are finally working. Now, an interesting thing to try out here is messing around with scopes. So if I do an assignment to X in the function, do we see that outside the function? So the function is being called there. So if we call X afterwards, what do we get? Do we get 5? No, we still get 3. Because the assignment, and this is what I was mentioning maybe a session or two back, because at the moment any assignment is just going to refer to variables in the innermost scope, because we and because we're not declaring variables anywhere, we're just assigning them or we're just initializing them. You know, there's no way of really you know, identifying a scope in which a variable exists. So, and that's where languages like for example I think a lot of more traditional scripting languages like Python, probably Perl, and PHP and things, why they have, you know, a global keyword so that you can refer to a variable in the outermost scope. Whereas in this case, well, I was considering introducing some kind of variable declaration mechanism in this language. So that would either be a let or something like Golang's assignment operator, like declaration and assignment operator. But whether to introduce that here, because the thing is, you're not necessarily going to, even though I'm talking about scopes here, yeah, that's one interesting thing about how I've done things here, and I've probably made a fairly critical mistake. Well, not critical because it can be fixed at any time at the moment, but scopes are being defined, say, on a function call basis. So when you call a function, and then if you call a function inside that, if there's, you know, it's a, and then you refer to some variable, like so yeah, I suppose I'll put on some code to make it more concrete. But if, you know, if I did something like function x, and I referred to a is equal to 3, and then I called function y, and then in function y I did something like print a, what a, because it's defined in the outer stack frame, and because of the way we're iterating through the stack frames, you know, a will be printed as 3, even though a shouldn't actually be defined in that environment. It should only be really accessing either the global environment, or if, you know, if there's going to be support for things like blocks and nested functions like this. So I've actually made a mistake in that regard, but at least the mechanism for handling those nested environments, at least that mechanism is working and can be used for at least defining things like closures, which would probably, yeah, I would say that would be a nice thing to have, at the very least, for allowing you to do kind of powerful thing, or you know, allow you to do things like parameter binding more efficiently without having to, you know, define an explicit function to bind the variables, even though, anyway, I'm kind of mumbling, getting lost in my own thoughts. So where to go from here? So I've identified that that issue with the current environment. Approach. So where to go from here? So there are a couple of things to consider. I suppose the first one is to make sure that each first of all, to remove that issue with the enclosing scopes, so that if you do call, in fact, I wonder if I ran some code. So if I comment the rest of that file out, can I actually demonstrate the issue that I'm talking about? That would be quite interesting. And if I call X, printing A should output 3. Unrecognized token. Where is the unrecognized token? Position 25. Can I only call perform function calls with non-empty parameter lists, perhaps? And same down here. Maybe I should. Oops. Anyway, I should get rid of that limitation. So B isn't defined. No, it is not. But it's outputting 3. Yeah, so that issue exists. And the other issue that I have is that I can't call empty functions with no parameter lists. So if I do a function call, oh yeah, that's because the function call syntax is still the way it was all the way back at the start, where functions can only be called with one variable, which is, we would say probably not such a sensible approach, but it's fine when you're getting started with writing the language. But don't think many production code bases limit parameters to just one. Let's see. Maybe in expression. Oh yeah, function call and can have one arg. And so where's the arg names definition? Yeah. And so we'll use that. And similarly, we'll allow a trailing comma at the end if we want. And so we have an expression list here. Want to have the same thing there, but we'll probably have to call it something else. So that's expression list. That would probably be a list expression list. This would be an args expression list. Or maybe param list. And that would be, so the head in these cases instead will be expressions. And this will now be a param list. And there'll be args, and a vector of expression. And because I set that up to be a vector originally, I don't actually have to update any of the AST stuff or the evaluation, so that's quite nice. It just naturally incorporated the result. And yeah, so in fact, so I'll go back to my test, remove those parameters that we don't need. And yeah, so we remove the parameters we don't need and get the result that we don't necessarily want. But at least the issue with it has been identified, and gives us an opportunity to correct it. So where to go from here then? I'll just grab my jotter. And so number one is only allow access to global scope and inner function scope. So don't allow access to the actual variables in the function called stack. I think what I was doing was I was mixing up the actual runtime stacks that you'd be implementing if you were implementing this kind of an interpreter from scratch and you were defining the actual stack. Whereas in this case, we're talking more about scopes rather than stacks. Scopes and yeah. So maybe even frame and environment are the wrong terminology to consider in this context. Might rename some things in that case. That's interesting. So we'll want to do that. And what else? I'm just thinking about nested function definitions and blocks and things of that nature. So I suppose the main thing, so we want to avoid that kind of runtime, that kind of messing up of the scopes in the call stack. But what we probably want to keep is want to allow this kind of stuff so that we can do a function z in here and modify a equals 4. And again, we won't be able to do that because we can't reference the outer scope at the moment. That's the thing we do want to allow, so that when we go down here and we print a, that this will be defined as 4, and this function as well should only be defined within x. So if we go down here and call z, that should be undefined. So let's see what happens so far. So what we're looking for here is, in order, y should print a, which should be 3. So I'm not looking at the actual output just yet. Then z will update the inner a to 4, but that will get dropped. And then the second print a, which happens after y, will also be 3. And then the z down there we will expect to be z is undefined. And yeah, that's currently what we're getting. Whereas eventually what we want to work towards is y will give us an a is undefined. The inner, so again, we need new syntax for this, but this inner call would result in the a afterwards being printed as 4, and then at the end, if we called z as well, that would also, yeah, z is undefined is what we want, so that's actually fine. The update to make is to make sure that we can't access the parent runtime scope, and make sure that we can access an outer scope. So I'm just going to take a moment or two just to consider what that might consist of, or how that might be achieved. So first thing of all, we do want to set up some kind of declaration syntax, and that'll give us a token error on the right, I believe, yeah. So we need some kind of declaration syntax so that we can refer to kind of variables in outer scopes, and so that we can tell the language when we want to refer to a variable in an outer scope. That'll be kind of nice as well, because I haven't, because one thing you can do in, say, the likes of Python is if I go, I could do if true, x is equal to 1. And then if I go x, the value is 1. Even though I haven't actually declared x in the outer scope, the way the kind of scope binding is set up, it's defined in the outer scope. Whereas I think, I don't know, like, again, it's a different scenario, so it's tough to evaluate. But what I think I'd prefer in general is that, is that you do something like this, and you have to define the variable outside the scope first, so that any variables defined inside the scope without that kind of setup will be dropped. But then it's difficult to know, depending on how it will be used, maybe it should be like, maybe this is more ergonomic. Maybe I'm just being a fuddy-duddy by being strict on that and saying, that's an inner scope. If you define a variable in an inner scope, then it gets dropped at the end of it. And it's not defined in the outer scope. I suppose it's something to consider. What are the pros and cons of that approach as well? It's not something I've looked into too deeply, so yeah, I suppose that's what's being dealt with at the moment. Anyway, going back to the immediate issue, the first thing to be done, and it's probably relatively straightforward, is to say that when you're calling a new function, you're not giving the total all the stack frames that are there. You're only giving, say, like, you're not giving the runtime stack frames, you're actually giving the definition time scopes, such as in the likes of here. And so in that case, how would we do that? It means that the environments that we're passing around here will be slightly different. And yeah, maybe I should call this scope instead of env. That's very interesting. Something I hadn't considered at all at the start, but it's making more sense to me to do it that way. And that would mean that instead of that's an interesting thing, actually, an interesting parallel. So what I was doing is that at the moment, it's every time a function gets called, a new frame is defined, put on the stack, and that's where the context that the new function will be called in. But what I will have to update it to is every time there's a new block, such as an if statement, for loop, while loop, anything like that. In those cases, a new scope gets defined and pushed on the, I guess, scope stack. And each time you go into a function definition, you do what? Yeah, same thing really. It's just changing the time at which you are adding new scopes to the stack from being the time of a function call to the time that a new block is introduced. So wonder how difficult that would be to do actually. So first of all, we'll go to our env push, and that's not right anymore. So env push. Yeah, so how will that be managed then? So it'll be that's a tricky one. So what's going to be pushed here in this case then? What's going to be pushed? Where is it going to be pushed, and what's going to be above it? Is anything going to be pushed, or am I just going to no, I'm just really not sure actually. So if I call a function f, and we have parameters a, b, and c. Where will they go? They'll have their own little scope there, where they'll all be defined, living happily. And then inside, if I do, for example, a let x equals 1, that will live alongside all the other parameters. And then if I do a regular y equals 1, and we say that that's referencing the global environment, then if I had a function g down here, and that had x, y, z, yeah, that's a tricky one. Yeah, not really sure how that's going to work now. But I'm happy with what I got done today. Anyway, that was a really nice result in terms of the environment and frames mechanism, even if it's ultimately not what I necessarily want or will use in the end. The fact that we were able to get something running, and something that is kind of parallel safe or thread safe. That's a fairly good result, I think. So anyway, yeah, today was just kind of like I was saying earlier, today is just kind of an extra stream, not necessarily part of the usual package. So I'm probably just going to finish it up there. Let's see, is there anything else that I wanted to do? No, that was more or less it. Yeah, I'm just going to probably think about this these scope things for a bit and try and figure out how that's all going to fit together. But anyway, thanks very much to everyone who's checked this out so far, and yeah, hope to see you on the next stream. Thanks very much. Bye.